Okay, I think I can finish this chapter in this video, so then I will do the lecture. Let's see. So now in the previous video, you may wondered you may thought it's too simple. So simply I considered investing in A and B at the same time. But in practice, that's not how a portfolio is made. A portfolio should have weights on multiple assets. So still, let's keep it simple so to have only two cases, so only two assets. And you are considering a portfolio of two financial assets, like say stock and bond or whatever. And say for example, then you may describe portfolio X like this: 30% invested on A and 70% invested on B. So out of 100% weight, how much is invested on where, right? So, and I will simply write it as a kind of coefficient: zero point 0.3 times A plus 0.7 times B. It is not wrong, so the dividend or return from X equals 0.3 dividend from A plus 0.7 dividend from B, right? Right, you buy like 3 stocks and 7 stocks from A and B respectively, for example. And we are going to use, what we are going to do is we are going to analyze the risk of X. By the way, we do not consider the mean because it's too simple, but of course in real investment, the expected return is the most important thing to consider. But in this practice, in this example, our focus is only on the risk, the variance, because we are studying covariance, right? So, and we will use these three formulas. First, remember, when you multiply A to a random variable, its variance is multiplied by A squared. You remember this from chapter 4. And second, when you multiply A to X and C to Y, their covariance is multiplied by A and C. And in the first two formulas, addition does not make any difference. But we are not going to add anything, so there is only multiplication. So plus B and plus D do not matter at all. And third, variance of X plus Y is variance X plus variance Y plus 2 times covariance, right? So we will use these three formulas, equations, to study the variance of X. Let's go. First, using equation 3, formula 3, variance of X can be written as 0.38. So X is something plus something, but something is not simple. The first something is 0.3 times A, and second something is 0.7 times B. But we may just use something in X, another something in Y. Then you can see variance of X equals variance of 0.3 times A, and then variance of 0.7 times B plus 2 times their covariance. Covariance of 0.3A, 0.3B, 0.7B. You may consider 0.3A as a new random variable transformed from A, like A prime, B prime, A prime and B prime, right? And using then, we need to calculate this, and this. And we are going to use the first two formulas. Variance of A prime, 0.3 times A, equals 0.3 squared times variance, right? Multiply 0.3 becomes 0.3 squared, right? And same thing, 0.7 becomes 0.7 squared. And when you multiply 0.3 and 0.7 for each variable, then covariance is multiplied by 0.3 and 0.7 at the same time. In the end, you have variance of x equals 0.3 squared variance of A, 0.7 squared variance B, 2 times 0.3, 0.7 covariance A and B. It looks quite complicated, but in each step, nothing so special. Just remember, variance is a kind of square, and square cross product has the same structure as variance, covariance. Variance corresponds to square, covariance corresponds to cross product. Then it can be understood naturally. And then because we know the variance of x, the variance of b, and the covariance between them, you may calculate the variance of the portfolio, right? But the number itself is not important here, but we are going to generalize that. In general, you may write it as weight W and the remaining weight 1 minus W. So W is investment weight on A, then automatically 1 minus W is the weight on asset B. And following the same steps, squared cross product, variance, covariance, and of course don't forget 2 is multiplied here, and excuse me. So this is the variance, the risk, and this is the starting point of the optimal portfolio theory. From here, what you learn in financial economics is to minimize the risk, minimize the variance, and find the optimal weight that minimizes the variance, right? You can just simply differentiate this and find the first order condition, second order condition, find the minimum, right? That's how you find the optimal weight based on risk, right? Which is exactly what financial economists do. Let's apply that same thing to real data again. Weekly stocks from 4 companies from 86 through 16. I took it from Yahoo Finance, real data again, and I chose four companies. So maybe the companies that have been like one of the best in their own period. So in the past, maybe in 80s, right after the oil shock, Exxon was the best. Maybe was the biggest company with biggest market capitalization, I think. And then Walmart took the top like in 90s, and then Microsoft and Apple, right? So what we are going to try a different portfolio and see how they work. So by the way, this table is covariance matrix. Covariance matrix, remember, it is a covariance matrix. The diagonal terms are variances. For example, 8.03 is the variance of Exxon, and 38.35 is the variance of Apple, right? So the diagonal terms are their variances, and off diagonal terms are covariance. For example, 5.83 is the covariance between Apple and Walmart, and 9.54 is covariance between Apple and Microsoft. Again, remember, we cannot compare which pair has a stronger relationship. Like 9.54 may be weaker than 5.83. You cannot compare their magnitudes, but you can just see that you can find that all the covariances are positive. So as you may expect in the market, when the market goes up, almost all the firms go up together, and vice versa. especially in the long run. Like we are considering 30 years. So in this long period, like the trend is usually positive because almost all firms go up together, like have a upward trend. So anyhow, and then from here, we do not care about the mean because it's a simple exercise, and we will consider 50% on Exxon and 50% on Apple. And if you invest 50-50 on Exxon and Apple, what would be the risk? Calculating the risk is like this. New portfolio X is 0.5 Exxon, 0.5 Apple. And use the formula, remember, using the portfolio weights, square cross product, and variance covariance, and 2 is here, and just plug in the correct number in there. If you put the appropriate number in each variance and covariance, then you will get 13.11. It's simple algebra, can be done on calculator, Excel or calculator, whatever. So what I wanted to show you here is the variance is much smaller than expected. It's greater than Exxon, greater than Exxon, but much smaller than Apple. So by diversifying your investment, the risk is reduced a lot. Like, right? It's closer to, even if it was 50-50, the resulting variance is closer to the lower side rather than the greater side, right? And then it's your exercise. Now it's your turn. Consider what happens if you invest 80% on Exxon and 20% on Apple. Structure is identical. Use the variance and covariance information from the matrix, and if you need, go back to the earlier slides and use some take some formula. Try this and pause the video until you finish the work. Okay, I'll show you the answer. The answer is quite surprising, right? Because the answer is 7.64. So by the way, first, it's mechanical, it's automatic. The variance of the new portfolio is weight squared, and cross product, and plug in the variances. And then you have 7.6. What's surprising here is this portfolio has the variance smaller than any possible single asset, right? So you mix two assets, but you made up even better than both of them, right? So this is the power of portfolio management, portfolio theory. So actually, I was surprised when I made this example. When you download the data, and I tried a few different numbers, but I was very surprised that actually it's going down. So I liked it. It's a great example to show to students. So I wanted to show you how we can utilize the covariance and the correlation coefficient in real world, especially the financial economics, and like which you may be very much interested in, I guess. Okay, the last word is that, again, do not rely too much on the covariance and correlation coefficient. Always check the scatter plot and see if there is any nonlinear relationship. The covariance is just a measure of linear relationship, so it may be misleading if the relationship is not linear. So I want you to look at the scatter plot, and for example, this is an example. When you see this kind of trend, covariance is, the covariance or the correlation coefficient is not an ideal measure to use for your analysis. So keep that in mind. And thank you for watching the video. And this is the end of chapter 11. I think I did it quicker than I expected, but should be fine. Okay, in the next lecture, I'm going to start chapter 12, which is the last chapter of this semester. See you later. Bye.